So the next one we're going to take a look at is another two-part question. This one has a person walks 15.8 degrees north of east for 1.79 kilometers. Now, this one's kind of nice because north of east, you might get lost in that a little bit, but it's basically the same notation that we've usually used. Basically, what it means is if this is due east, then we would go 15.8 degrees north, so up from that. It looks like this. In fact, this is actually what we're already used to because east would be the 0 degree mark. So it's just, let's see, 1.79 kilometers at 15.8 degrees is how we would actually write it. So 1.79 kilometers. And you'll notice that this is measured from the positive x-axis, so that's perfectly fine. North of east, whenever you're using that notation, whatever the second one is, so east, you would start pointing that way, and then you would go however many degrees, 15.8 north of that. So to put that in perspective, usually on maps, we have to the right is east and up is north. We talked about that a little bit in class. I don't prefer using that notation, but it does show up in real life applications. So I thought this would be a good one for us to look at. All right. Then, let's see. Another person walks due north, then due east to arrive at the same location. How far due north would this person walk? Okay, so what they're saying is the first person walks in a straight line like this, and the second person goes up like this, and then over like this. They go due north and then due east. They ask us about due north first. Now, there are a couple ways that you can go about solving this. We've got a triangle here, and it's a right triangle because of our coordinate system. East and north have 90 degrees between them, so that's great. We know that the total length of this vector is 1.79 kilometers, so that's our hypotenuse. Now, the obvious way, from the way they've described it, because they said the other person walks north and then walks east, we could go through and we could solve this triangle. Now, how we would do that is, this is a right angle, so we could take, instead of 15.8 degrees here, we could find that these two together have to be equal to 90 degrees. I could take 90 minus 15.8, and I would find that this angle is 74.2 degrees. I'm not going to write that in, you're going to see why in just a moment, but you could do that with 74.2 degrees here. You could then solve this triangle just fine. In fact, might be worth giving that a try. However, here's what I'm going to do instead. And what you can do is you can kind of double check your answers compared to this. Now, you saw this in class. It doesn't actually matter which of the ones you do first when we're trying to work these out. I can then put it like this. If instead they walked east first and then north, we would still end up with the exact same outcome. Now, you are welcome to go through and do the 74.2, but here's what I'm going to do. I'm actually going to set it up this way, and we'll solve it this way. So check your answers, see what you come up with. Granted, your numbers might be a little bit different, but something to actually check out. In this case, it's a lot like some of the others we looked at. We're going to go with a triangle, so we've got SOHCAHTOA. All right. We know the hypotenuse. We know one of the angles. Let's say they asked for the northward component first. They said, how far due north would this person walk? So we're looking for the north component, the y component here. Now, with this being my angle, it's across the triangle from that. So we would use the one that has the hypotenuse and opposite. I'm pointing at the wrong one. We use sine. Sine of 15.8 degrees, I'm going to fill in some of my numbers, equals my opposite. Let's call that the path north. I'm going to call that PN. Path north, the thing that we're looking for. So that's the opposite, path north, over the hypotenuse, which is 1.79 kilometers. Now, as we've seen before, I'm going to multiply both sides by 1.79 kilometers to get what I want, the path north by itself. 1.79 kilometers. We're going to go through and we're going to double check this. Let's see, sine of 15.8 times 1.79, and we get that how far they walked north, the path north, is going to be 0.487 0.4, it's 738, so yeah, 0.487. And then our units, kilometers, so that's kilometers, a little bit less than half a kilometer. Now real quick, I'm not actually going to write it on the board, but if we had done instead the way that it was originally set up, and this was our angle, 74.2, you'll notice that this isn't the opposite side anymore. For that angle, it's the adjacent. If you do cosine of 74.2 times 1.79 kilometers, solving it the other way, you still end up with the exact same 0.487381642. It's exactly the same. You could solve it this way, or you could solve it this way. Both of them are the same. All right, I've shown you this way. We're going to stick with this. Now we want the eastward component, so I'm going to call that PE for path east. So let's go with cosine, because for this angle, that's the adjacent side. So cosine of 15.8 degrees equals the adjacent side, which is path east, divided by 1.79 kilometers. I'm going to skip writing this out. It's going to look exactly like the one above. We're going to do cosine of 15.8 times 1.79 kilometers, and we end up with that the path east is going to be equal to 1.72 kilometers. There's part 2. You're welcome to go in. Now remember, if we had it in the original configuration, with the angle here, this one would be the opposite, so we would use sine on that, sine of 74.2. If you use those, you will find that you come up with the exact same thing. Yay, math. All right? So now we've got